Everyone. The objective of this video is just to provide you with more practice using or really solving problems involving a sample proportion in regards to its sampling distribution. So in this problem today, we have a polling organization that asks a simple random sample of 1,500 first-year college students how far away their home is. Suppose that 35% of all first-year students attend college within 50 miles. Find the probability that the random sample of 1,500 students will give a result within 2 percentage points of the true value. And we are going to follow the four-step process. Now, the four-step process is just a way to break down this problem because it is pretty involved. There are a lot of steps that we have to follow in order to get this probability. In the previous assignment, I pretty well broke down everything for you, as in like part A, find the mean, part B, find standard deviation, part C, check conditions. Instead of listing all of those questions individually, we are just going to follow this four-step process. And that's pretty well how the AP exam is going to be formatted whenever you take that. So anyhow, let's actually start this problem. So state, pretty obvious. We just want to state what it is that we are actually trying to do. We are trying to find a probability. We are trying to find a probability. The probability that we're trying to find is our sample proportion from these 1,500 students is within 2 percentage points of this value, the true value. The true value is in regards to the population. We know that the true value is this. The true value is the population proportion is equal to 35% or 0.35. And again, we're just trying to find the probability that we are within 2 percentage points of that value. So in my little statement up here, I can write it out as p hat, our sample proportion, needs to be greater than 0.33, but also less than 0.37. Again, this is the probability that our sample is within 2 percentage points of the true value. This is what we're trying to find. Now, with a sampling distribution in regards to a proportion, to find this probability, we are going to try to use a normal distribution. But we'll get to that in just a second. For the plan part, this is helpful because anytime you are solving problems regarding a sampling distribution, you're pretty well going to want it to be a normal distribution as well. So for the plan, it really just involves this. We need to, always for this plan step, we are wanting to check conditions for normality. We want to see if our distribution, our sampling distribution, is going to be approximately normal. Now, there are 3 conditions here. The first condition to check, the sample that we collect has to be randomly selected. Easiest condition to check as well. Going back up to your problem, make sure somewhere in there they've done an adequate random sampling technique, which they did. An SRS, that is a simple random sample, like dropping names into a hat or using a random number generator. And that's perfectly okay. That's one way of randomly selecting. If it said up here that they did a convenient sample, it would not meet this condition. But again, since they use an SRS, absolutely, this is random. The second condition that you're going to want to check is the large counts condition. Large count. So this one is a little bit more involved and it requires a little bit of calculation. The large counts condition is the one where we want to make sure that the number of successes and failures is greater than or equal to 10. And it's written out like this. The size of the sample times the probability of success needs to be greater than or equal to 10. And the same is true for the failures, which is just the sample size times 1 minus the probability of success. And again, this needs to be greater than or equal to 10. So plugging in some of our values, we know that the sample size is 1,500. And we were also given the probability of success. The true value here was 0.35. Now on the number of failures, it's pretty much the same thing, but the probability of failure, 1 minus p, is 0.65. Okay, we'll do these calculations just to make it clear. I think it is already clear, but 1,500 times 0.35. We get 525. That is plenty of successes. Now we will check the number of failures, which is just 15 times 0.65, and we have 975. 975 is absolutely greater than or equal to 10. So we have enough successes, we have enough failures, we now pass the large counts condition. The last condition might be the most challenging, the 10% rule. This one guarantees that we have enough variation in the sample. So the 10% rule says that we need to sample less than 10% of the population. Now the issue here is we know that our sample size is 1,500, but we were never actually given the population size. We don't know how many students there are at this college. And that's really common. You're not going to be given the population size very often, but it's not the biggest issue. All you would have to say is, well, since our sample size is 1,500, we would have to assume that the population size is at least 15,000. We would have to assume that there is at least 15,000 students at that college, which is a reasonable assumption to make. I think most state schools are probably in like the 30,000 range, so this would pass. We can assume that. That's a fair assumption to make. Had we said that maybe the sample size or the population size needs to be at least like 250,000 at one college, then it's probably not so much a reasonable assumption. All right, so since we passed all of these conditions, we will move on to the do step. Very helpful anytime you're working with a sampling distribution where you're trying to find a probability and it is normal, actually draw your normal curve. So we know that our distribution is normal. A sampling distribution will look something like this. Now to fill in this sampling distribution, there are some statistics that we need to find. We need to find the mean of this sampling distribution. We need to find the mean of the sample proportion. What is the most likely outcome? What's going to happen most often? That's the center of it. And this one is easy to find. It's always equal to the true proportion, P. So in this case, the mean of our distribution is going to be at 0.35. I will mark that right here. The mean of 0.35 is our center. Now, another thing that we need to know is how spread out is this data going to be? And we find that using the standard deviation. Now, the formula for this in regards to a sampling distribution, as we discussed in class, it is the square root of the probability of success times the probability of failure divided by the sample size. So let's plug in some values here. Standard deviation would then be equal to 0.35 times 0.65, all divided by 1,500. So you can do this all in one step on a graphing calculator. It is the square root of 0.35 times 0.65 divided by 1,500. And we get something pretty close to 0.0123. We'll go with 0, 1, 2, 3 because it's like a sequence. Okay, there's our standard deviation. So going back to our normal distribution then, for a sampling distribution of p-hat, we can say that one standard deviation away, that value would be at 0.3623. Two standard deviations away would be 0.3746. And this would be our third deviation away over here. You can find it if you want to, but it's not really going to matter for our problem. But let's subtract a couple times. 0.35 minus 0.0123. 0.3377, okay. 0.3377. Let's do that one more time at least. 0.0123. Whoa, I didn't put. All right, let's try this again. 0.3377 minus 0.0123. 0.3254. And then we can also calculate our third standard deviation, which is like best practice. Always go 3 standard deviations to the right and 3 to the left. So 0.3131. Fantastic. So we've got this thing sketched. We found the statistics that we needed. Now we can actually finally answer this question. Remember what we were trying to do? Back up here in the state step, we're trying to find the probability that our sample proportion is between 0.33 and 0.37. Always draw that on your normal distribution and shade it in. We know that 0.37 would fall probably around right here. On our distribution, and we know that 0.33 is going to fall somewhere in between this range, maybe like right here. All right, and what we're trying to find is the probability that we fall within that range. So then you could just shade this in. It looks a little nicer than mine. It's hard to shade in with a Sharpie. All right, now to find this probability, there are, of course, a couple options. You can find z-scores for each proportion. Look up those corresponding z-scores in table A. Find their associated probabilities and do a little bit of subtraction to actually get this area. Or you could also just use normal CDF. And that's what I'm going to do. Using normal CDF. Now, when you do this, in terms of showing your work on the AP exam, they're going to want you to specify exactly what you put into this function. So the first thing that you type in is the lower bound restriction, the lower amount. Then you can type in the upper amount, and then we can plug in our mean and our standard deviation. So normal CDF, how to get there is second, and we'll click on vars. And normal CDF is that second option. The lower amount that we would be using is 0.33 up to 0.37. The mean, as we already said, was 0.35. And our standard deviation, we're going to round a little bit, but it should be fine. 0.0123. I'll just jot those things down on my function that I already kind of started creating. 0.35 for the mean and 0.0123 for the standard deviation. Okay, I'll go to paste, hit enter one more time, and there is our probability. 0.896. Get us pretty close. 0.896. Fantastic. Now that we have the probability, let's just write a little conclusion statement that summarizes what we did. The probability that our sample proportion the probability that our sample proportion is within 2 percentage points oops, 2 percentage points of 0.35. That was that true value that we were using. It's approximately, because we did do quite a bit of rounding, is approximately 89.6%. And that does it. So these problems, they're long. There's a lot of steps involved. I'm going to zoom out and show you everything that we did. A lot of stuff to break down, but follow this 4-step process. Make sure you state the problem that you're actually doing. What are we really trying to find? In this case, it was a probability. When you're finding a probability with the sampling distribution, we're probably going to answer that question using a normal distribution, which means we have to plan, we have to check conditions. Random large counts, the 10% rule. The do part is all the calculations. So we are going to have to find the mean and the standard deviation, draw a normal curve, shade it in, and then you can just use your calculator to actually find the probability, and then just write a conclusion statement that kind of wraps up your problem. We know that the probability of our sample proportion is within 2 percentage points of 0.35. And again, we calculated 89.6%, which makes sense if you look at our normal distribution. We shaded up quite a bit of it. All right, hope you enjoyed the video. I'll see you all in class. Bye-bye.